we're going to compare the values of two different functions on the same graph. So in this situation, a parent uses two identical hoses to fill up a small pool that is 15 inches deep, this one right here, and a large pool that's 27 inches deep, this pool right here. It says it takes 6 minutes to fill up the small pool, and the height of the water is a function of time since the water was turned on. So the first thing we want to do before we compare these two pools is we want to make a graph. So I know that they're going to fill at the same rate, and I know that it's going to take me 6 minutes to fill the small pool. That means at 6 minutes, the small pool is going to have 15 inches of water. So somewhere 6 minutes, it's going to have about 15 inches of water. So this is going to go straight up till we get to that point. Now I want you to think about it. At that point, I have to turn the water off. And so when I turn the water off, the water's still going to be in the pool, except it's going to flatten out. We're not going to get any more water in the pool. So this is what that graph would look like. Okay, this is the small pool getting filled up with water. Right here we turn the water off, and then we continue to have 15 inches of water in it. Now the large pool is going to fill up at the same rate, but we can fill this until it's 27 inches high. So this one's going to look a little different. It's going to come up here, but when we get to 15 inches, it doesn't have to stop. The large pool is going to continue being filled till we get to 27 inches, and that's where we'll turn it off, and that's where it will flatten out. So the green line I have down here represents the water in my small pool, and the purple line represents the water in my large pool. Well, now we're ready to compare these two functions. And the question I want to answer is, which pool has more water at 12 inches? So first of all, let's find where 12 inches, at 12 minutes. Let's find where 12 minutes is on our graph. 12 minutes is right here. Now you might be able to look at this and say, okay, I think the large pool is going to have more water, and I can tell that because when I see that, my line, my purple line here for my large pool is much higher than my green line, which means it has many more inches than my green pool did. Okay, so we can see that on the graph. But let's just see what we would do mathematically to show this. Because if you're asked to prove your answer, we can do that mathematically using our function notation. So this is saying, how deep is the water at 12 minutes for the small pool? And what I would say is, at 12 minutes, we have 15 inches of water. And how deep is the water in the large pool at 12 minutes? So again, we go to 12 minutes, we go up to our large pool, we come across and we see that that's 27 inches of water. So we have our 15 inches of water for our small pool, we have our 27 inches of water for our large pool, and then what we're going to do is we're going to compare those two amounts. And I would compare them with this symbol. The small pool has less water than the large pool at 12 minutes. Okay, this graph looks a little more complicated. It's showing two different populations, one for Baltimore and one for Cleveland during the 20th century. So the Baltimore population is marked by this blue line, we can tell that right here, and our Cleveland population is marked by our red line. Okay? The first question we want to answer, it says, estimate the population for Boston in 1930 and explain what it means in this situation. Okay? So, if I'm looking at 1930, that's right here. Okay, so I can come up here to where I hit my blue line, because remember my blue line is Baltimore, and then I'm going to go over and see that we have 800,000 people in Baltimore. Okay, so this means that in Baltimore, in 1930, there are 800,000 people. And we're going to use this graph now. We can compare using greater than, less than, or equal to. So the first thing we want to compare is the Baltimore population in the year 2000 compared to the Cleveland population in the year 2000. So let's look at the year 2000 right here. And you might notice right here, my Baltimore line is above my Cleveland line. The blue line is higher than my Cleveland line, my red line. If our line is higher on the graph, that means it's got a higher population. We can just look at our y-axis to tell us that. So looking at this line, I can see that the population in Baltimore is greater than the population in Cleveland. Well, what about in 1920? Let's look over here. If I look at these two lines, I can see that my Cleveland line is bigger because it's up higher, and my Baltimore line is smaller. It's less than, okay, because it's below it. So what I would say is the Baltimore population in 1920 is less than my Cleveland population in 1920. And you'll notice I did this one without even looking at the specific populations. Okay, I could just know that if it stops here, then this line is going to be higher. It's going to have a higher population because it's higher on my graph. And then are there ever any times when the two cities have the same populations? If so, when? Well, I can see that right here and right here, we have the same population. The way I can tell that the populations are the same is because my lines intersect, which means they're at the exact same population at the same time. So in 1910 and in about 1944, we have the same populations. We're going to do a couple more questions on the same graph here. This time we want to explain how we can tell each statement is true. So I'm going to tell you these statements are true, and we're going to translate that description into function notation. So it's true that in the year 2010, Baltimore had more people than Cleveland. Okay, if we look over here, in 2010 we can see Baltimore has more people than Cleveland because my line is higher. So the way I can tell on my graph is my Baltimore line, the blue line, is higher up on the graph than the Cleveland line, the red line. The way I would write this in function notation is I would say my Baltimore population in 2010 is greater than my Cleveland population in 2010. Okay? In Baltimore and Cleveland had the same population twice, in 1910 and around 1944. So again, if I look up this, we've talked about this. These are the same because they intersect here. Now, how would I write that? I'm going to have to write this using two different function notations. The first function notation would say that the Baltimore population in 1910 is equal to the Cleveland population in 1910. And then my second notation would say the Baltimore population in 1944 is equal to the Cleveland population in 1944. All right, and finally, my last two. In 1920, Cleveland had more people than Baltimore. So if I look at that on my graph, 1920, remember we can see Cleveland has more because my line is higher. The Cleveland line is higher. So, So I can tell because my red line is higher than my blue line. Now the way I would write this, Cleveland's going to come first because Cleveland comes first in my sentence. So my Cleveland population in 1920 is greater than the Baltimore population in 1920. Now watch this. Over here we're going to flip-flop it. This time we're going to say Cleveland has less people than Baltimore. Because if we look over here in 1980, Cleveland's line is lower. Cleveland has less people. So I can tell that because the Cleveland line is lower than the Baltimore line. And the way we would write it in function notation, remember Cleveland still comes first. So the Cleveland population in 1980 is less than Baltimore in 1980.